Hello everyone, this is Professor Chan for Math 1245 talking. We're going to continue on and we're going to do section 3.4. So 3.4 essentially deals with the situation of finding zeros for polynomials, except this time we're going to be talking more about imaginary or what we call complex numbers, okay? Now, ideally, you should know what complex numbers are, okay? But let's just do a quick thing that we want to talk about. So, complex numbers, if you recall, is what's called a plus bi. It's in the form of what's called a plus bi. So, a plus bi. And so, the idea is this is your real, and this is what's called your imaginary. One of the rules that we want to talk about is remember, complex numbers comes in what's called conjugate pairs. So what does that mean? That means they come in pairs of two. So if I have an imaginary number of a plus bi, then I have an a minus bi, okay, for the following. So if I look at this example right here, so for example, this one here, so since we have a zero that it gives us is 3 plus 2i, I also have a conjugate of 3 minus 2i, okay? So if you have a plus I, right, you'll have the opposite for the following. So notice the numbers are exactly the same. The only thing different is a plus and a minus. So that's something to take in mind, okay? So the idea is they may give you a bunch of zeros, okay? And it'll be a combination of complex plus real solutions, okay? So the idea is they want you to write a polynomial with real coefficients at the end, okay? So I have degree 4, which means I have 4 zeros. My zeros is 3 plus 2i. I have a conjugate of 3 minus 2i, and I have 4 with a multiplicity of 2. So when I write this out, right, it's going to look like this. F of x is equal to x minus 4, right? Remember, we do opposite of my solution. So my factor is the opposite sign of my solution. And since it's a multiplicity of 2, I put 2 on top here. Now, the second part I have is x minus parentheses 3 plus 2i and x minus 3 parentheses 3 minus 2i here, okay, for the following. So what I'm going to do now is I am going to essentially distribute my polynomial just so that my i's are no longer existing. Okay, I don't want i's in my polynomial because I want real coefficient or real numbers at the end. Okay, now I do not need to actually multiply everything out. Okay, I don't want to do that because obviously it's going to take us a lot of time, and it's also really easy to mess up. I just want to distribute enough such that so my i's go away. So I'm going to ignore the x minus 4 part. Okay, that's kind of already taken care of. What I'm going to do is I'm going to distribute this negative for both of these. So I have x minus 3 minus 2i. And I have x minus 3 plus 2i, right? I'm taking my negative, I'm distributing it. So all I have to do is I just have to FOIL everything out. So I have x times x is x squared. X times negative 3 is negative 3x. X times 2i is 2ix. Take my negative 3 and then distribute across. So negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. Negative 3 times 2i is negative 6i. Then I'm taking my negative 2i and then distribute across as well. So I have negative 2ix plus 6i minus 4i squared. Okay? Now, what should happen is as long as you distribute things correctly, is that your I should kind of cancel out. So notice the following that we have right here. What I notice is I have my 2ix canceled out with my negative 2ix. my 6i's and my i's cancel out. So I'll just kind of simplify this out. Okay, so the thing I also have to realize is remember I square, according to complex number rules is -1. Okay, let me just combine my x's. And then I realize -4 times -1 is +4. Okay, and as you can see, all my i's disappear, so that is a good sign. Okay, and so I have x squared minus 6x plus 13, and I have x minus 4. So this is my polynomial. Okay, now as you can see right here, this is how I end this. I do not need to distribute this any longer, okay? Because all I care about is that my real coefficients end up at the end, right? I just get rid of my i's once I distribute, and that's fine, okay? So, and it makes sense. We have a degree. I have an x minus 4 squared, so that's x squared, and I have an x squared, so I have x to the 4th, which gives me 4 zeros. So let me show you one more example of this right here. Okay, so yeah, let's do number 1 here. I feel like I should do this one just because it's a little bit more tricky. So I have degree 4, which means I have 4 zeros. So if I have a I as a 0, that means I have a negative I. If I have 1 plus 2i, that means I'll have a conjugate of 1 minus 2i. So these are all my zeros. So the way that I'll write this out is it's going to be x minus I, x minus negative I, x minus parentheses 1 plus 2i, and then x minus parentheses 1 minus 2i. Okay. Now let's talk about, so some of you guys are probably wondering, okay, as I'm simplifying this part out, some of you guys are probably wondering, like, which ones do I distribute to each other, okay? And if you notice from our last problem, I essentially distribute my my parentheses to the ones that have conjugate pairs to each other, right? So if you notice that x minus I and x plus I, I'm going to multiply those together. And then the x minus the 1 plus 2 i's, I multiply those together, right? I don't want to cross multiply for my i's and 1 plus 2 i's because they're not conjugate pairs of each other. So if you notice, right, I'm going to multiply the first two parentheses together because they're conjugates. And I'm also going to multiply the second pair together because they're conjugates. I'm not going to multiply like the first and third or second and fourth, right? I just want to make sure that the same pairs are being distributed out. So let's look at the first part. This will be x squared plus ix minus ix plus I squared. I'll just do this one part. I'll do the first half first. So ix and negative ix cancels out. And this, remember, I squared becomes -1. So I have, sorry, my bad. Let me do that part again. Sorry, when I distribute, it should be just minus I squared. So this is minus -1, and hence it'll be x squared plus 1. Okay. When I distribute my x's, this is going to be the following. It'll be x squared minus x plus 2ix minus x plus 1 minus 2i. And I have minus 2ix plus 2i minus 4i squared. So this cancels. So all my i's cancel except for the negative 4i squared. Let me bring the rest down. Negative x minus x is negative 2x. Okay, and then my I squared turns into negative 1. And I have the following here. Okay. Okay. So these problems right here can be a little bit tedious, as you can see already. Just be really careful. A big indicator is if you notice if your i's are not canceling, that probably means that you either have the wrong conjugates or you're just not multiplying and distributing things correctly. Okay, so make sure you know how to do your horizontal distribution, or in some cases FOIL. Make sure you know how to do that correctly. Okay, otherwise it's not going to work. Okay, but you just have to practice. Okay, and just do your best. And then once again, if you stop right here, right, if you see where kind of my pen is, right, you don't need to multiply the x squared plus 1, x squared minus 2x plus 5. You don't need to multiply that out. Okay, that's going to take too long, and you're probably going to mess up. You just need to distribute enough so that your i's, or your imaginary parts, just kind of go away and cancel out. Okay, so what does this have to do with everything we've been doing? The idea is simply the fact that you will also be doing polynomial zeros, but you may have complex numbers this time. So let's look at something. Let's see. Let's see. I'm going to start with something like number 4 here, okay? So we're going to do the same thing that we've been doing in the last video. So I'm going to find all my zeros, right? So I have x cubed, so I'm trying to find 3 zeros. And then also write my polynomial in its factored state. Okay, so let's talk about this right here. So what are my potential zeros, right? If you remember, p is 16. Okay, and then you factor this, it's 1, 2, 4, 8, 16. And my q is 1. So p over q, remember your potential zeros, or pz for short, I'm going to write as plus or minus 1, 2, 4, 8, 16. Okay. Now let's talk about this right here. So remember, let's remember, if you forget this, okay, go back to the last video so you remember how to write potential zeros. Now remember how we kind of remember to make our lives a little bit easier. We're going to use our graphing calculator, and we are going to graph this for the following and see where my zeros intersect. Okay, so I have x to the third minus 4x squared plus 4x minus 16. Now, when I graph this, I'm going to set my window, right? So I'm going to go from negative 16 to 16. The reason why, right, is because that's part of my potential zeros. And I want to make sure that I don't cut off a potential zero that may cross my x-axis. Cross or touch, okay? So we're going to graph it. Okay, so let's go back to negative 10 to 10 so we can kind of see clearly. So it looks like it crosses at x equals 4. So remember, notice it's crossed, so that means it's odd. Okay? And it's most likely, right, it's going to be my x equals 4 will have multiplicity of 1. Okay? Now here's a thing to also keep in mind. If you notice, your graph does not cross 3 times, right? Nor does it touch, right? It crosses the x-axis only once, okay? And since I have x to the cube, that's actually a huge indicator that I will have an imaginary number. Sorry, that I'll have complex numbers as my solutions, okay? Because complex number solutions will not show up on your x-axis. So notice I have x cubed, but it only crosses once. That means the other two has to be a complex root, okay? Now this is important, right? Because this here, the x equals 4 is my only known 0. So if I do not immediately spot this, right, you're just kind of stuck and you can't really solve this problem, okay? So I'm using synthetic division. I have x is equal to 4. And let's look at this. So I have 1, -4, 4, -16. I'm going to bring, right, 1 down. 1 times 4 is 4. And that's 0. 0 times 4 is 0. 4. 4 times 4 is 16. And I have 0, which is a good sign, right? I don't have a remainder. So let's talk about what does this become. This is x squared plus 4. Okay? I'll set that equal to 0. Okay? Now, here's the thing. I can use quadratic formula, right? If you do negative b plus or minus square root of b squared minus 4ac over 2a, right? I will still get the correct answer. Okay? But to make life simpler, I notice I don't have an x, so all I do is move to -4 and then solve for x squared. Now, if I take the square root on both sides, remember the rule. If you take the square root of a negative number, you have to pull out an I. Square root of 4 will become 2i. Make sure you do plus minus. As you can see, I almost forgot. So always remember when you take a square root for an equation, it's always plus minus because there's 2 of them. So my zeros, what are they? My zeros are the following. It's going to be 4, 2i, and -2i right here. When I write it in my polynomial form, let's talk about how do I write my polynomial out. My polynomial function out. So I'm going to have f of x is equal to, so I have x minus 4, right? That's my factor. Now, some of you guys are wondering, how do I do my complex zeros, okay? Okay, here's the thing. You could, if you really want to, do the x plus 2i, right? And x minus 2i, and then multiply it out and get your answer, okay? But that's kind of not necessary, because here's the thing. You actually already have it. It actually comes from this. Well, after you do your synthetic division, right, you're left with x squared plus 4. So this is actually going to be part of your answer. You already have your factored form. So this will be your final answer. And that's it. Okay. Let's do one more example. Let's see here. Okay, so yeah, you know what? Let's do number 3. Just because it's a little bit longer. Okay. So here we have 4 zeros. My potential zeros, P is 60, okay? And unfortunately for your potential zeros, you may have some ridiculous large amount, and it does happen. So think of all numbers that divide into 60. 1, 2, 3, 4, 5, 6, and then 6 divides 60, 10, 12, 15, 20, 30, and 60. Okay, now some of you guys are wondering like, man, there's so much things that divide at 60. How do I remember them all? Okay, remember you still have your calculator. Okay, so if you're like not sure, just divide it. So you're like, okay, does 60, is it divided by 5? Yes, it is, right? I get 12. Is 60 divided by 7? Right? No, it's not because I get a bunch of decimals. Okay, so go down the list, okay, for the following here. Okay, just to make sure you don't miss anything. Q, thankfully for us, is just 1. So, potential zeros is just actually everything in P because we're only dividing everything by 1. So plus or minus 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. Okay. So when I graph this, I will have to change my windows drastically. So let me type this in. I'm going to graph it. Okay. So let's just talk about the following here. So obviously this is way too large, but I do see it's definitely closer to my y-axis. So I'm going to take a stab at it. I'm like, okay, maybe it's just only from negative 10 to 10. I think. Let's take a look. Okay, so this is good, okay? So let's talk about this right here, okay? If you look at your graph, notice it crosses the x-axis at this point, which looks like it's at x equals 1, and it looks like it crosses at x is equal to 6. 1, 2, 3, 4, 5, 6. Okay, here's the thing too. Remember, if you're not sure, you can go to second graph, and you can look at your table, right? Or you can do second trace and hit value and then type in, and then you can kind of guess. Like, is it -1? Yes, it is. Okay. Now remember, if it crosses, let's talk about this. So if it crosses at x is equal to -1 and x equals 6, that means it's odd. So your only possibility is either 1 or 3. Okay. So if you think about it, it can't be crossing 3. Your cross can't be 3 because 3 plus 3 would be 6. So they both can't be 3. So either one's 3 and one's 1, or more likely is they're only going to have a multiplicity of both 1. Okay, and that's probably the safer bet. So let's look at the following. I'm going to do -1 for my synthetic. So 1, -7, 14, -38, -60. Okay. Also, a quick reminder, if you are skipping, right, your degrees, you must put a 0 in your synthetic division. So make sure you remember that. Okay. So we don't need it. We don't need to because it's all going down by 1, right? x4 cube square x and a number. Okay. So 1 times 1 is -1, -8. 8, 22, -22, -60. Okay, good. And a 60. So I can clearly see I did it correctly because I don't have a remainder. Okay, if I do have a remainder, that means I either screwed it up or this is definitely not a factor. But when I look at my calculator, it clearly says that there is a 0. So your calculator is very useful for the following. Okay, so let's look at, we have 6 as our potential other 0. So let's look at 6. And then remember, you keep reducing as you go along. Don't start over, okay? Because that's not going to be helpful. You want to actually reduce as you go along. So I have 1, 6, -2, -12, which is 10, and then 60, and we're good. Okay, we're defining here. So let's take a look at this right here, okay? And you're like, what do we do with the x squared minus 2x plus 10? Well, yeah, so if you notice, you can't factor it, right? Because, yeah, so it's definitely not factorable because the only two things that multiply to 10 is 5 and 2 and 10 and 1. There's no combination that would add up to negative 2, okay? That's also proof that we will not have a multiplicity of 3, okay? So what do? We're going to use, right, quadratic formula, okay? Yeah, and this can be a little tedious, but it will happen. So I'm kind of showing you what to expect here. So I have minus negative 2 plus or minus square root negative 2 square minus 4 times 1 times 10 all over 2 times 1. So I have 2 plus or minus square root 4 minus 40 over 2. 2 plus or minus square root of negative 36. Let's split this up. So I have 2 over 2 plus or minus, I'm going to pull out the I, square root of 36i over 2. Okay, so I have x is equal to 1 plus or minus 3i. So what are my zeros? My zeros are the following. They are going to be negative 1, 6, 1 plus 3i, and 1 minus 3i. So those are my zeros. How do I write my polynomial? So let's talk about it. So your polynomial function in factored form. So remember, let's talk about the following, right? So these real roots will be the opposites. So you say f of x is equal to x plus 1 and x minus 6. Remember, they're opposite. Your factored roots are the opposites of your zeros. And then remember, don't do the conjugates and multiply it out because that's going to take you too much work. Remember, it's going to be the quadratic that's left over after synthetic division. So this is going to be x squared minus 2x plus 10. And I'll be this right here. And this will be your final answer right here. So that's pretty much it for finding polynomial zeros. Okay. The only thing is, the only thing that is a little bit different is be very careful with complex numbers. Make sure you know how to do quadratic equations correctly. Quadratic formulas correctly. Make sure you know how to simplify your radicals. Okay, all those things are important, like rationalization, simplifying radicals. Make sure you know how to get rid of your i's. Okay, those are kind of basic fundamentals that you want to make sure you're good at. Okay, and I kind of expect you to know that in order to be in this class. Okay, if you struggle with that, please practice that. If you're my co-rec, please definitely practice that as well. Okay, and then if you notice too, in some of these other problems, sometimes they give you the zeros. So example number 2, they give you 0, 3 minus 2i. You should immediately realize that you will have a conjugate of 3 plus 2i. So remember, anything with i's, right, you'll have a conjugate pair. So you should always have 2 of each. Okay? So Let's do the last thing. We're going to talk about Descartes' rule of signs for the following here. So, essentially, yeah, and you can kind of read this out. Essentially, it's just the number of positive real zeros is either the same number of sign changes in f of x, or less by a positive even integer. Okay, so part B is a little confusing, but let me give you an example. Okay, so if I have, say, 5 sign changes, then I would have potentially have I could have 5 positive zeros, or 3, or 1. So you see that they're going down by 2s. Okay, so if I have like 7 sign changes, if I have 8 sign changes, then I could have 8 positive zeros, or 6, or 4, or 2. Okay. Okay. And then a negative real zeros is kind of the same thing as well. Okay. So it says less than the number of sign changes of f of negative x. Or sorry, f of negative x. If f of negative x has only one sign, then it'll have exactly, it'll just have one negative real zero. Okay, so let's talk about this right here. Okay, so let me give you an example for number 1. So let's take a look at number 1 here. Okay, so let's look at f of x. Let's see how many sign changes there are. So notice it goes from the following here. So notice I go from number 1, I go from positive to negative, so that's 1. Negative to positive, that's a second one, and positive and negative, right? So that's 3. So what is that saying, right? We are saying that we could either have 3 positive zeros, or I could have 1 positive zero, because I'm going down by 2s. Okay. Now, this is not really helpful to us. Okay. So what I'm going to do next is I'm going to do f of negative x. Okay. So I'll do 5 negative x cubed minus 3 negative x squared plus 3 times negative x minus 1. Okay. So I have negative 5x cubed minus 3x squared minus 3x minus 1. Okay. Now if you notice here, it does not change sign at all, right? It's always negative the entire time when I go from term to term, as opposed to positive. So that means I have 0 negative zeros. So that means if I look at this, this is my only possibility, right? So my zeros are either positive or negative. Since I have no sign changes, that would make it, for my f of negative x, that makes it, I have 0 negative real zeros. And then by default, that means I'll have 3 positive real zeros. Okay. One thing to keep in mind is when we say the word real, real includes both like natural numbers. I'll take that back. Yeah, we're not actually including imaginaries in these cases, okay, for the following. Okay. So let's look at one more example. I'm going to look at number 3 here. Okay. So let's look at f of x. Let's see how many times it changes signs. So I have 4 zeros. It changes once, right? Positive, negative, negative, positive, and positive, negative. So what is that saying? We have either 3 positive zeros or we have 1 positive, because remember I can subtract 2. Okay? Let's look at f of negative x. So this is 4x to the fourth. This will be positive x cubed. This will be positive 5x squared. And this will be minus 2x and minus 6. Let's see how many times it switches signs. So it's positive, 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 but then it switches to negative, but then it stays negative. So that means I have exactly one negative 0. So looking at this, right, the only possibility that would match according to my positives is 3. Okay? Because let's talk about this, right? We have 4 zeros, so I have 3 positive zeros and 1 negative 0. Okay? So this one's a little bit odd, okay? This theorem's a little bit odd. Just make sure you practice this, okay? I would say this one's not as essential compared to the other parts, but do take a look at this. Again, if you have questions, feel free to email me or post onto the discussion board. Okay? But we're going to end this, and we're actually done with section 3.4. So we'll start with 3.5 in the next video. But other than that, I will